Hi, and welcome to this session at Raise 2020. And this session that we are having today is actually a very exciting session. The topic of the session is scaling AI research to solve big societal problems. And my name is Vivek Raghavan, and I'm the Chief Product Manager of Aadhaar, of UIDAI. And I'm very happy to be the moderator of the session here today. And we've actually got a very excellent panel of speakers today. We have one keynote speaker, followed by six other speakers, each of whom will give their views on this topic. And finally, and then we'll have a session, hopefully we'll have a Q&A session with some of the participants in this session. And finally, there will be a demo of an example of where AI has been used to demonstrate an impact to solve a large societal problem. So that's the focus. So to set the stage, let me talk a little bit about why is this an important question to ask, right? So one of the things that we see is AI is obviously wherever you go, people are talking about AI. AI is certainly the buzzword which is there, and the number of people who are doing things with AI, and many times even to solve societal problems, are actually doing POCs. Okay, so you're doing actually things, small things that work here or work, and you show some benefit. But then the point about it is, for it actually to make a difference to society, you need to be able to scale it, and you need to be able to make it work in a large scale. And I think that there are certain important principles that make that happen. The first thing, of course, is we must integrate into existing platforms. And existing platforms could be government platforms. It could be the mobile phone as a platform, but it must integrate into existing platforms that people use and systems use. And that's when you can actually use it to solve large scale problems. The second, in my opinion, a second important thing is that if we are doing something at scale, we must use open source technologies. That's very important because firstly, for two reasons, right? It can't be proprietary to any given company. And the second thing, of course, we also it needs to be open to understand whether AI is being used fairly in the context of solving societal problems. Now and I think so. I think that's another key thing, that when you're building something at scale, open source plays a very important role. The other part is, of course, is AI fundamentally works on data. And there are two important points that we need to look at as far as data is concerned, is that we need to create open data sets, or we need to leverage existing data sets. And I think that creation of data sets and exploiting of current data sets in a form that can be used by sophisticated AI algorithms is critical. And many times these data exists, and then it needs to be put into a form that can be used by AI systems. In other cases, it may not exist at all, and we have to come up with innovative ways of collecting that data. And of course, if you have to do something, you have to build at scale. And that's something that's very important, because it's very easy to do something small, but how do you build it at scale, and so that it impacts and actually solves a real problem. And then, of course, the final thing is that you need to bring in the ecosystem. And many times what happens is, and create components which can be used by other players in the ecosystem, so that we have ecosystem innovation to actually solve some of these problems. So I just wanted to set the stage a little bit about, what does it mean? And I think I'm sure the various speakers today will have lots of very interesting things to talk about. So without further ado, I'm going to go to the first speaker of the day and our keynote speaker, and that is Dr. Manish Gupta. Dr. Manish Gupta is actually the director of the research lab at Google India. And obviously he's a renowned computer scientist with a background in deep learning across video analysis, education, and computer systems. And I think that in addition, he is a distinguished alumnus of my alma mater, IIT Delhi. So I think that Without further ado, Manish, over to you.
Thanks, Vivek. So let me share my screen, and I hope my slides are visible. Oops. Are my slides visible?
No, we can see your screen, but not the slides.
Okay. How about now?
Yes.
Okay. Great. Okay, thanks. So I'll talk about the work that we are doing at Google Research India on applying AI to problems inspired by the Indian context. And of course, we hope to have impact both on India as well as beyond India in this process. So all of this is work done by my team. So I'll cover 4 topics today. I'll talk about our work on healthcare. We have this AI for social good program where rather than going to Google product groups, we go to NGOs, which are working on various problems affecting different communities. And we ask them to describe what are some of the tough problems that they are facing, where we saw AI could make a difference. And so I'll share some work that we are doing over there. Then some work that we have been doing on remote sensing that we are planning to now start applying to problems related to water sustainability and agriculture. And finally, making information available in Indian languages, right? So today we all use Google whenever we are looking for any piece of information. How do we make that information available to every Indian, regardless of whether they're able to speak or understand English or not, right? So in their native language. And a lot of this work, this is all done on a foundation of, again, a fair amount of fundamental research that we do on advancing the state of AI itself and on human-computer interactions. Because when we look at these AI systems, there's a different way in which we see humans interacting with these AI systems. So let me start with healthcare. So I would argue that every country on the planet is trying to figure out how to improve its healthcare system, how to improve quality while lowering costs, right? And the key to doing that, in my view, is twofold. One is make healthcare more consumer centric. That's more of a business model change rather than being very provider centric the way it is today. And that's where you have, again, business model changes like concepts of managed care, where you're and insurance-led healthcare, where you're giving a certain sum of money to take care of people, and then you incentivize healthcare providers to take better care of people in that amount of money, rather than be incentivized for spending more on healthcare. The other aspect is to make it proactive, and this is where AI can make a significant difference. And by proactive, I mean basically, we've all heard the saying, prevention is better than cure. So that saying can be applied to the various tiers of a healthcare system. And the most expensive tier in a healthcare system is usually the ICU of a hospital. And as a doctor famously remarked, that's the most expensive place to spend your night in an ICU. It's more expensive than uh, renting a room in a 5-star hotel in a fancy exotic location. And it's not a particularly fun place to spend your night. So if you can take care of the person before they need to enter the ICU, it's not only leads to lower cost, but also better outcome for these people. And the same argument keeps applying all the way to different tiers, that it's better to take care of a person at a primary healthcare center than having to have them go to a super specialty hospital. And taking that argument even further, if you can take care of people when people are living their normal lives at home and at work, that's far better than having to go to a doctor. So I'll now give a couple of examples of how AI can enable this proactive approach to healthcare. Um,
So,
and so let me start with the
Manish,
example
Manish,
of diabetic.
sorry to this thing. The slides are not moving.
Oh, really? Oh,
Yeah.
sorry about that. Uh, oh, it's saying, okay, your sharing is paused. Let me share my entire screen and see if that makes any difference. Can you see the slide on diabetic retinopathy now?
Yes, we can.
Okay. Okay. Uh, so, uh, so diabetic retinopathy is again, I mean, one of the growing causes of blindness, and potentially any of the over 400 million people in the world who have diabetes, they are at a risk of this condition. And the way it is, and what happens in India is often there's a severe shortage of doctors, and therefore we find roughly 45% of the people suffering a vision loss before they are diagnosed with this condition. So that motivated us to look at, could technology be applied, right, to help again these relatively small number of doctors, right, take care of the entire population's needs. So how's it diagnosed? How's this condition diagnosed? So what an ophthalmologist does is they look at this retinal fundus image, which is again the image of the retina taken with this camera, and they look for signs of hemorrhage. And then they rate this case on a 5-point scale, um, starting with no diabetic retinopathy to proliferative diabetic retinopathy. So what our researchers did was they said, can we apply all these deep learning techniques that have been used on this image classification task, right, to, let's say, distinguish whether it's an image of a cat or a dog. So the kind of techniques that went into products like Google Photos, can you apply them to these retinal fundus images and help diagnose whether it's a case of diabetic retinopathy? And again, I mean, I'm cutting, not going through all of the details, but after a fair amount of hard work and improving kind of the various algorithms and so on, the team showed that yes, they were able to achieve results that were comparable to those shown by ophthalmologists. And they published that work in the Journal of American Medical Association. And this paper got again a fair amount of praise from the medical community. You can see this quote, the study by Gulshan. So Varun Gulshan is the person from India Research Lab who in fact started this work, and his colleagues truly represents the brave new world of medicine. And in fact, earlier this year, this paper was rated amongst the 10 best JAMA papers of the last decade. And in fact, later this team went to improve these results even further uh, by utilizing techniques like a proper adjudication process. So one of the things they found was that often ophthalmologists themselves did not agree on certain complicated cases. So in those cases, we referred those to the retinal specialists, and we asked them to, again, typically a team of 3 retinal specialists, and we asked them to independently um, uh, judge these cases. And if they independently came to a consensus opinion, we took that as ground truth.
So, Manish, we are not able to hear you. Um, so I don't know. we are having some technical difficulty with Manish at this stage. I don't know. So should we maybe we can move to the next speaker and then we can come back to Manish. Maybe that's probably the best way of doing this. Is that okay? So the next speaker is Professor Manindra Agrawal. And sir, are you ready to present at this time? So then if that's the case, then we can move forward that way, sir.
Sure. I'm fine.
Yeah. So Professor Manindra Agrawal is, of course, is a highly renowned and distinguished person. He is Professor of Computer Science at IIT Kanpur and also Deputy Director. He has been the recipient of the first Infosys Prize for Mathematics and also the Shanti Swarup Bhatnagar Award in 2003. And he's a Padma Shri awardee in 2013. And for those of us who are have interest in theoretical computer science, he was responsible for proving the AKS primality. And so therefore, without further ado, Professor Agrawal is going to be talking about the usage of AI in agriculture and forestry. So without further ado, over to you, sir.
Thank you. Let me just start with sharing my presentation. I hope it is visible. Is the presentation visible?
Yes, sir.
Yes, okay, excellent.
Yes.
Let me just figure out how to prepare slideshow. Okay. So good morning, everyone. It's a pleasure to participate in this panel amongst the real experts of AI. As Vivek said, I'm really a theoretical computer scientist, no expert in artificial intelligence. However, as my responsibility of Deputy Director at IIT Kanpur, I did get involved with a number of large-scale projects of the institute. Some of them were related to agriculture and forestry. And in those discussions, realization dawned that there are some very specific problems for which AI can play a fabulous role in solving them. And these are large-scale issues. Solution to them can benefit the society tremendously. And so I'll limit my presentation to just these two domains, which is not to say there are not other very important domains, and I'm sure other speakers will shed light on those. But since my understanding in these two domains is a little better compared to others, so I'll just limit myself to this one. Perhaps a most significant impact that AI can make in the lives of common people, and realizing that a very large fraction of our population are farmers. So therefore, the impact in agriculture domain can lead to tremendous benefits. This is an idea which I am told is being seriously discussed in the government, and there are plans to create what we call a comprehensive agriculture information system. Once it is built, what it will do is it will bring out all information related to agriculture, be it the pattern of weather in different parts of the country over past several years, the availability of water, also the predictions for the future, that is up in the coming year, of what will be the rainfall, how will the weather pattern change, how will groundwater situation improve or decay. The consumer demands also keep changing. Then all the land holdings all over the farms, which are geotagged properly, along with the soil conditions. The marketplace as it evolves for agriculture, various financing avenues that are available. So all this, if it's brought on a single platform, it of course is a very large amount of data. So just doing straight away simple analytics is not going to be as useful as machine learning, AI-based analysis of this information and extracting useful directions from it. They can help farmers by telling a farmer what crops should he plant for the upcoming season, how his yield is best sold in the marketplace. Also, if he requires uh, some financial assistance to plan for the crop, what are the best avenues available for that. Some of it is already happening, but it's kind of disparate. And also, there is no proper global level analysis that is being done. Every farmer almost plans locally what to do in the next season. Whereas if there is a full analysis done of based on consumer demand, weather pattern, soil condition, marketplace, etc., it can significantly improve the productivity of our farmers and also the price that they get for the crop they develop. It's also will be a great tool for the policymakers to take a holistic view and plan out how they should, where the aids should go, which part of the country needs support, and based on the yield, how much to procure, and so on. And no, it goes without saying, the investors, those interested in investing into agriculture, can derive tremendous benefit from this in terms of, again, their planning and where should they direct their money to. So a collection of data of this kind at a very mass scale, and then at that large scale applying the analytics based on AI on it, can really do wonders to the agriculture economy. Many of us would know that the productivity of Indian agriculture system is not as high as it should be. And there are so many inefficiencies in these processes which can be addressed to a large extent through this. So that was one learning for myself, which I am thought I will share with everyone. In the forestry, perhaps it is not of that big an impact, but it is still extremely important for the society as a whole to take good care of its ecosystem, the other species, the forest. Each one of them play a critical role in the overall health of the society. We keep hearing about the man-animal conflicts because of the increasing population of humans and decreasing forest covers. Many species are endangered. So, a number of these challenges can get good support through AI-based techniques. Just to take a couple of examples, if you have certain areas where there is a large probability of a human-animal conflict, then perhaps those areas can be wired in a way, or some surveillance mechanism can be deployed there in a way so as to alert the authorities that about an impending situation. And again, the kind of surveillance data that will come out of this will be at a very large scale, and therefore we would need AI-based tools to extract important information from this. Similarly, another major challenge that lies about the tracking and counting the number of endangered species. For example, the National Tiger Project keeps track of the current status of tigers, and the counting the tigers is also a very challenging job. Very expert humans have to spend large amount of time in the forest to actually identify different tigers. Over a period of time, the forest departments have moved to automated tools to uniquely identify tigers. And this is where AI can also play a very important role to help keep track of endangered species and also raise the necessary flags if there is a challenging situation that comes up. So these are the thoughts that I thought I will share from my own understanding about where use of AI can make a very significant impact to our society. Thank you.
So thank you, Professor Agrawal, for your insights of the use of AI specifically in the areas of agriculture as well as forestry. I think one of the challenges, sir, and that's something that we have to understand, that I think that building this system is actually, I think the techniques and the technologies exist. Collecting the data within our existing systems seems to be actually the bigger challenge. Maybe just maybe a quick comment on you on how you think that data can be collected in a scale that can be used to solve. I mean, if all this data were available, we could solve these problems. But how do you see that that can be?
Yeah, that's a very, very important point, and thanks for highlighting this, because collection of data is, as you rightly said, is a tremendously challenging task, given the state of, let's say, various processes in our country which are not necessarily very high quality. So the data that comes out can be error prone, and so one needs again tools to make better sense of that error prone data, to clean it up and so on. Again, this is another domain where AI techniques will play a very useful role. Also, some of the data collection can be automated. For example, if you want to, let's say, estimate a forest cover, instead of asking humans to do it, why not fly a drone with a suitable camera outfitted, which can survey the area, get you a very detailed information. If some lidar-based, surveillance equipment is there, you can get extremely detailed forest information. So these are the things that one will have to work on and come up with a suitable mechanism for the collection of data. And in just about each one of them, because of the largeness of data, AI has to play a crucial role.
Yes. Thank you, sir. Thank you very much. I think, sorry for the technical difficulties earlier in the conference. Now Manish is back. So therefore, Manish Gupta from Google will continue his presentation, and we'll take it from there.
Okay,
Manish.
Yeah, I'm really sorry about the technical glitch. My laptop crashed. So again, I'll resume, and apologies for all this issue. Okay, so yeah, so I was talking about diabetic retinopathy. Let me move to another example. So cardiovascular disease is one of the major killers for people, again, across the world. In India, a very unfortunate kind of fact is that close to 80% of the people who suffer a heart attack or a stroke are actually not even aware that they have a high risk of these adverse events from cardiovascular disease. But the good news is that through a combination of, if only you were able to kind of provide that early warning to people, and if they were to take certain simple measures in terms of lifestyle modifications and some very simple medical interventions, there's a potential to add roughly 10 to 15 years of healthy life to so many people who are suffering these heart attacks and strokes. So the idea is to take these sensors, which are available in things like mobile phones, wearables, cameras, and monitor various conditions related to, one is the various body vitals of the person, as well as kind of the exercise they're getting, the food that they're eating. So if you can convince the person to show you photographs of the food that they're eating. You can then apply computer vision techniques to estimate not only like the calorie values, you can estimate kind of what kind of food it is, and therefore if it is prepared in a typical manner, how much salt content it is likely to have, and so on. And with uh, all of this analysis done to these kinds of sensor output, you can actually get some very rich signals that can, when analyzed further, you can come up with risk scores for whether this person is at a high risk for cardiovascular disease. And if the person is at that high risk, there are simple lifestyle modifications like exercising more, limiting your salt intake to no more than 5 grams per day, and likewise keeping your blood pressure under control if you continue to have this hypertension. These can dramatically lower your risk for, again, these adverse events like heart attacks and strokes. And a similar kind of, again, infrastructure can actually help us with many other forms of diseases, diabetes, and again, in various forms of cancer, early detection is really the key to achieve better outcomes. So we believe, again, AI can make a very significant difference in helping us catch these things early and again, suggest timely interventions. Now, switching gears, in our AI for Social Good program, we went to these NGOs and working in areas like public health, in fact, wildlife conservation and education. And we started, again, identifying problems where AI could make a difference. So I'll just cover one of them. This is our work with this NGO called Arman, which is focused on improving maternal and child health. So what they do is they send these voice messages get delivered over the mobile phone to expecting mothers. So every week of the pregnancy, and then in the first 6 months after the child's birth, these helpful messages get delivered over the mobile phone. And women who participate in this program, Arman has shown clinical studies that show they end up with much better health outcomes compared to women who don't. And the unfortunate part is, due to a variety of reasons, many women end up either dropping out of the program, or they find like fewer than 50% women actually listening to 70% or more of that content, even those are very short messages. So here again, we worked with our collaborators from IT Madras in developing these AI-based models to predict who were at a higher risk for dropping out. And these AI models were able to predict over 80% of these women who later dropped out of that program. And so it's been deployed in production at Arman, and they're using that to now reach out to these women in special ways, not just a notification, but also there's somebody who calls them and then tries to keep them engaged on this program. And they are now trying to measure the actual outcomes. So we have this Earth observation science team, which is applying computer vision techniques to satellite images. And Vivek, to the question that you asked Professor Manindra Agrawal just now, right? What would be a way to kind of look at some of these problems, right, in agriculture in a scalable manner? So our view is that if you can kind of train these models, initially you need data, ground truth data. For instance, if you're trying to do soil moisture analysis, you're trying to identify a crop, what kind of a crop it is, you're trying to estimate the yield, which becomes important for, like, let's say, providing better priced crop insurance or credit to the farmer. You can train these models using ground truth data that you get through these maybe sensors. But then if you can train models that take satellite images or drone images, as Professor Manindra just suggested, then you can do these things in a far more scalable manner. So as one example of that, we are working with the Earth Engine team to, for every point on the map, can you do an automatic classification of land use, land covered. Is this an agricultural area? Is this a forest? Is this a water body? And so on. And you can imagine this kind of an analysis can help you figure out things like what's happening to forest cover in a given region, what's happening to water bodies. We are also working with this flood forecasting team. You'll later see a presentation by Sela on automated riverbed mapping. And we are now talking to a number of partners, including startups working on agriculture related problems. And we see that, again, applying these techniques to, for instance, satellite images that kind of cover a crop being sown in a given region, they can help you with various kinds of problems that arise. So for instance, one of the problems that arises is that today farmers cannot get crop insurance coverage at a reasonable rate. Often crop insurance is outrageously priced, maybe close to 1/3 of the overall crop price, which is unaffordable. And that's because the insurance companies, A, don't have a very good way of estimating their risks, and B, their operational costs are very high. So our view is that if you can now help them with these scalable techniques, based on, for instance, satellite images, where you're giving them estimates of how much of the actual land is being used for growing a certain crop for which farmers are buying insurance and so on, you can actually provide these insurance, provide this credit to farmers at much lower costs and help them, again, improve their income and so on. And final example I will give is, again, democratizing access to information. So in India, again, I mean, we have products like search. Google has a product called Assistant, which allows you to access information using voice-based queries. And in fact, Assistant is now supported in 8 Indian languages in addition to English. And in fact, Hindi is the second most used language for Assistant globally after English. But what we see is, again, as we have deployed this, right, in the real world, not just in a lab setting where you had a few, trained models for different languages, we are seeing all kinds of really, really fascinating issues arise. Things like code mixing, that people in India, we tend to mix multiple languages, right? Instead of asking a query in Shuddh Hindi, I would often mix up words from Hindi and English in my query. And then even when people are typing queries in English, often they are making spelling mistakes very much influenced by their native language. So if I'm a Hindi speaker, I might spell furniture in this manner, which is shown here, the spelling. And if I'm a Bengali speaker, again, I might spell a certain English word in a specific kind of a manner. So can you, again, kind of apply natural language processing techniques to understand all of these phonetically kind of very similar variations of spelling, right? And be able to identify these kinds of queries accurately. And then how do you extend knowledge graphs to be able to support, again, representation of knowledge that is arising from non-English sources. So one of our initiatives is we are developing this framework called Mural, multilingual representation for Indian languages. And we have started with 16 Indian languages in addition to English. And we have shown very significant improvements over the current state of the art. That also comes from Google, a multilingual version of BERT. And we have shown significant improvements over that. So one final point I would make is that as we start to see AI being applied to help, again, society, help people with various problems, it is also very important for us to keep certain principles in mind. Principles like avoiding creating bias, right? So we've again, and be built and tested for safety. So I was referring to, for instance, as you start to have healthcare, AI being applied to healthcare, these systems are only aids to doctors, but as doctors come to rely on these aids, how do you make sure that your deep learning algorithm, when it is making a certain prediction on, let's say, diabetic retinopathy, how do you make sure that in cases which are complicated cases where this algorithm is also prone to making an error, it can also indicates its confidence level? Because we humans, when we see complicated cases, we do recognize, right? So doctors are able to recognize that this is a complex case, and therefore let me seek a second opinion from my colleague. Whereas a deep learning algorithm could very confidently give out the wrong answer. So how do you calibrate these kinds of systems? And I've seen, again, people like Sunita, they've done a lot of very good work on these kinds of problems. So we need to, again, make a lot of progress on many of these deep learning techniques themselves, AI techniques themselves, in order to really kind of ultimately conform to these principles that we have laid out. So let me stop here and say that, look, what I have touched upon are just a few simple examples, and that is just the tip of the iceberg. There are just amazing opportunities in terms of really applying AI to solve some of these problems at scale. But at the same time, there are also outstanding challenges. There's a lot of progress that is needed in the AI technologies themselves, and in terms of, and in understanding the interactions of these AI systems with humans to be able to make really progress the right way. So let me stop here and again apologize for all the issues during my presentation.
Okay. Thank you, Manish. Thank you, Manish, for that wonderful presentation. Now that maybe I will ask you also one small question. I mean, obviously, we when we think about scale, we think about Google. Google is one of the companies which has established using AI at scale. So, but my question to you is that many of these things for social good, it actually involves both the government as well as the private companies. And how do you see that? And sometimes there are actually issues of trust, etc., which lie between these two things. How do you see that you can actually, figure out how to make sure that the two entities can trust each other and work better for social good, number one. And number two is, what is your commitment? I know that Google develops lots of wonderful products, but I want to understand the commitment to open source, specifically, the solutions that you have, so that the entire ecosystem can understand, and also the understanding of bias and things like that is only when things are open source can we understand that that things are actually being done in the right way in that case.
Right. So those are great questions. So Vivek, on the first point, I would say is, first of all, again, I think we are committing to abiding by these principles. So of things like fairness, transparency, and so on. And again, I mean, companies like Google, right? Sometimes, I mean, there are all these concerns, right, about are you handling data appropriately and so on, right? So we really take these things very seriously. And in fact, there is also work being done at Google, right, on technologies like federated learning, through which we are showing, right, how can we start to get these benefits, right, of some of these technologies like NLP, as well as AI applied to healthcare. How do you start applying it to data in a privacy preserving manner, right? So that some of those concerns about, are you kind of getting access to all of that data, right? And kind of including sensitive data, right? That the people may not be comfortable, right? Sharing with any company for that matter. So we are making progress, as well as through our commitment to these principles, we are laying the foundation of, look, this is how we would approach these problems in a responsible manner. And in fact, we also are doing additional research on how do we kind of understand some of these problems of responsible AI in the Indian context. Because, I mean, when you talk about fairness, India has so many additional dimensions of diversity, right? Language, religion, caste, and so on. So how do you start to understand those issues of fairness also from the Indian lens? So that's kind of one part. your other question about open source, yes. So in many cases, we are really looking for ways in which we can actually enable the ecosystem. So for instance, on our AI for Social Good program, we are really moving in a manner that pretty much all of the work that we do together with these NGOs in areas like, so in addition to this public health, we recently did some work with Pratham Books on, again, transliteration tools to support some of the underserved languages like Konkani and Maithili. And so together with our academic collaborators, we are releasing those technologies in open source. And in fact, this mural work that I talked about, we are right now going through, again, the approval process. Our intention is very much similar to how all these BERT embeddings and so on were released by Google in open source to allow the practitioners, the NLP researchers and practitioners, right, to take advantage of the pre-training that we were able to do, right, on those large corpus of data. Likewise, with Mural, we are again looking into ways in which we can release this work in open source, make it available to the research community as well as the practitioners, so that they're able to build solutions, better solutions for, let's say, supporting with better support for Indian languages, right, in the Indian context. So again, I mean, it's above my pay scale to talk about open sourcing Google's search code. I don't think that will happen, but yes, there are other ways in which we are looking at how we contribute to the community.
So thank you so much, Manish. Thank you for a wonderful presentation. Moving on ahead, we are now going to have Gaurav Sharma. He's the Vice President of IBM India Software Labs, and he drives the broader mission of leading the IBM hybrid cloud platform, Cloud Paks, and the public cloud across Asia Pacific markets, and is a global executive sponsor for the Global System Integrator Partnerships. One interesting thing about Gaurav is that he is passionate about contributing to various initiatives, including the Niti Aayog's Atal Tinkering Labs for education and skills development. And so without further ado, I will hand it over to Gaurav to take us through the next session.
Thank you, Vivek. Everybody able to hear me properly?
Yes, we can.
Okay, so thank you so much. It's such a privilege to be here. Professor Manindra, then Manish, who's been my senior and guiding light for all of us, and Vivek, you, and all the other panelists, which we get an opportunity to listen. I think it is extremely important, this session, and I'm getting WhatsApp messages that it's such a power-packed session. So, and there's so much diversity of thought which is coming out. But one of the most important things which I actually read about maybe 2 to 3 months back is AI is just not a buzzword and could become the general purpose technology. And what that means is it will not only affect pockets, but it will affect the society in general in years to come. And I think as an Indian and in India, I think we have a great opportunity to be the leaders in this technology, both from a commercial perspective and from a society perspective. A society develops when each individual develops, right? And I will request Shiv if we can share the first slide. Okay, I think we're all set. So all of us know that AI is already being leveraged to tackle a lot of moonshot challenges like cure for cancer, climate change. IBM has been involved in a lot of these, whether it was the moon landing or even now, whether bringing the first AI-powered astronaut assistant or something which we launched about a month back, which is known as the Mayflower autonomous ship, which is very interestingly 6 AI-powered cameras, 30 onboard sensors, 0 human beings, and the captain is actually an AI captain to provide a safe, flexible, cost-effective way of gathering data about the oceans, or it is about scaling the quantum computing for the next generation. However, something which is very interesting to see is AI can be used as effectively or at a similar scale that do not require scientific breakthroughs, but can actually add to existing efforts to help individuals or groups. And that is where the focus of my talk would be, not looking at the moonshots itself, but areas in which we can really contribute with the AI capabilities which are coming out, taking care of the risks, taking care of the challenges which come, and obviously making sure that it is very, very ameliorative. And with ameliorative, I mean it is a tolerable, it is equitable, it removes the bias. Domains which actually link to the United Nations sustainable goals like treatment delivery, prediction prevention in terms of health, or climate adaptations, animal, plant, air, land, water conservation. Professor Manindra talked about forestry, and there's one example which I saw where they were tracking animals, and it had a significant impact in the last 3 to 4 years, probably not in India, but somewhere outside, or whether it is disease outbreak, migration crises, which we have seen, search and rescue and disaster management. But what will be required would be specific AI capabilities which can be used for societal benefits. And some of them I have tried to categorize is would be more like natural language processing, computer vision, structured and unstructured, both deep learnings itself, right? And obviously the challenges and risks that come along with that. So challenges are more towards the workforce displacement that may happen, right? It could be the data accessibility or the risks which comes along with it, which can make it more adaptable, like bias, privacy issues, which was talked about. There was one other very interesting topic which Professor Manindra talked about, is about the data itself, right? And in our experience, what we have seen in typical AI projects, 75 to 80% of actually effort goes in fixing the veracity of the data itself, making sure it is accurate, complete, and other stuff. So we can move on to the next slide, please. I'll go through some domains where IBM research is involved and accelerating discovery, whether it is capturing and transforming carbon dioxide to mitigate the climate change, whether it is producing fertilizers itself, sustainable ways to grow crops, rethinking batteries, developing more sustainable electronic devices. I'll not go deep into all of them. But what I would like to say here is there's a significant research which is going on, and IBM calls it 5 in 5. And these 5 top technologies in the 5 years which will have a significant impact. It roughly takes about 10 years and upwards of $10 to $100 million on average to discover one new material with specific properties. We really want to cut down the years and the cost by about 90%. Basically, what AI will do is it will consolidate all of humanity's knowledge on a specific topic. It's a global challenge that we want to address. Then supercomputers, and eventually, if quantum computers are applicable to that domain of problem, quantum simulations will cover our knowledge gaps. And using the past data and AI obtained, we create models to generate hypotheses. And finally, we'll automate the making and testing of these materials, thereby hoping that in 5 years, what is taking you today 10 years and upward of nearly $100 million would be cut by about 90%. Moving ahead to the next slide, I really want to go through one capability which has played a role. IBM has been involved in the first one, Deep Blue. Actually, Manish was the lead for creating the system Deep Blue. So it's a privilege for Manish to be here sharing the stage. Then in 2011, you saw Watson Jeopardy. And now an interesting thing which is launched last year, was Project Debater. Now, it's interesting that eventually Project Debater will help people reason by providing compelling and evidence-based arguments and kind of limiting the influence of emotion, bias, or ambiguity. And I do think that this will be critical because it's just not a keyword search, right? It develops a much deeper understanding of the topic at hand, constructs a point of view, and then it constructs a speech as well, and then it rebuts. So I would urge all of you, if you can just type IBM Project Debater on Google, there's a debate ongoing. You can participate in that debate, and I think within the next 9 days or something, you'll see that the AI system will start debating with you in a way which collects all this information. So the natural language processing, and why I want to emphasize here is an area which actually fits directly into a lot of AI use cases which are being used for societal benefit. Moving ahead I'll pick up one challenge, which is on the mitigating risk itself. Can you go to the next slide, please? Right. And this is, I think, one of the most pet topics for everybody, whether it is fairness, robustness. And with robustness, what we mean here is fairness, everybody understands. So I'll not go deep. We have limited time. Any AI system is not infallible and may be vulnerable to adversarial attacks, right? So IBM Research is working on defending AI systems from malicious attacks. We heard the previous speakers talk a couple of times about safety and security. And that is one of the most important things for scale. If you cannot make AI systems safe and secure to consume. So far we have been talking about people who are developing AI solutions. But the consumers also need to feel safe, trusted, and secure, or whether it is explainability or transparency and accountability, which is there. With trusted AI as the foundation, AI capability that will pivot aspirations to scalable adoption in advances in natural language processing along with deep learning. They are increasingly being used to support human decision making. While AI holds the promise, broad adoption will rely heavily on the ability to trust their output, right? And these are the 4 topics which are going on. I would like to let everybody know. You can just say trusted AI, IBM Trusted AI. There's an AI Fairness 360 toolkit. You can download it, use it. There's an adversarial robustness 360 toolbox. There is an AI explainability 360 toolbox itself. And very interestingly, we wanted to get these research topics back to the products itself, because that is where we have seen the benefit when it starts getting available for people to use. So we have Watson OpenScale, which detects drifts, which debiases AI models, and which starts explaining AI outcomes. We can move to the last one, which is very close to my heart itself, which is basically how do you turn AI aspirations to outcomes? So when I was working with CII and NASCOM and other things, Vivek, so it's very interesting that while trying to think about what we are, in what space we are from an AI adoption perspective, we started creating a kind of a ladder. So this is not it's not a formal ladder per se, but this is where we have seen and read and experienced. There's an awareness, then there's acceptance, there's adoption and absorption. Most of the projects actually today are at the adopt phase, where very point solutions, POCs going on, right? Absorption will come when we put people and culture and their benefit at the center. If you are using my data to generate some knowledge, which eventually helps you, how is my data eventually helping me itself as an individual? It should be very, very tolerable, right? How much workforce displacement will be required? How much upskilling will be required? What are the kind of skills which will be required? And the most important thing is, I think there was a topic which came in as to how private and government will work together. For these societal problems, we'll have to have skunk works. It will have to have open innovation, like Vivek, you said. Interdisciplinary skills, synthesizing minds will be required to actually create that impact, right? So at a lot of places we have seen, obviously awareness, we have to drive it in the next decade or so if we have to lead for the next 100 years. Acceptance is coming in. Acceptance will start coming in when I start trusting the information. Adoption, when I start seeing some results which are beneficial to me. And absorption, when it starts impacting the society and each individual at the entire pyramid in an extremely positive way. So thank you so much for the time. I think this is so enlightening for me. These sessions are always a learning session for me. People like Vivek, Manindra, Manish, and other people as well who will be coming in. And thank you for the opportunity. And I do hope and wish that not only societal problems, but India does become an AI society per se, so that we get our rightful place in the future. Thank you.
Gaurav, let me interrupt you. You should learn to remember women's names also. All the other panelists are probably women. I
I'm so sorry.
strong objection to it.
Lavanya, Shailja, Sunita, Gaurav. Oh, again, Gaurav
Please.
came.
So I think we are seeing an example of human bias. So maybe AI bias
Of
will.
course.
No.
But no,
Of only women. I have only IBM fellows and Ds as women.
But seriously, Gaurav, thank you for an excellent presentation. But I would like to ask you the same question. That you've talked about lots of wonderful technologies that IBM is using AI in. But what are their commitment to open sourcing AI? I know that, for example, with Red Hat, you've moved into the open source space, but that's not necessarily AI. But I want to understand that what is your commitment to open source, and what is a specific problem that you want to, a societal problem that you want to work and try to solve in India as opposed to a global view?
So the first thing is open source didn't start with IBM from Red Hat. I'm not sure if many people know, 20 years back, IBM committed $1 billion to Linux, right? And Spark, and we have more than maybe 30 or 40 or maybe 60 technologies which we have contributed back to open source, including our IP as well. In terms of AI, a lot of the things that you see, even if you look at our packages and other things, they run all open source. So it can just plug in and start running. It does not matter where you have developed it. Now, for some of the things, whether the biasing models and other things, what we have created, I will go back and take shelter behind Manish's comment. I am too small a person to say what maybe the uniqueness of all these algorithms when it can be open source. To your question for India, we are involved in 3 or 4 very significant areas, Vivek. The first one is agriculture. For the last 3-4 years, in fact, our engineers from the labs actually spent a lot of time in a very small village in Andhra. So I think Arvind talked in the keynote session along with the Prime Minister. In education, for example, the entire NITI platform which Atal Tinkering Lab uses, and it's very interesting that we were the first ones to start getting students from class 7th and 8th into the labs as interns for 2 to 3 weeks. Now that's a huge kind of a process change that is required to get kids inside. The third thing which we worked with was ICMR and the health there itself. So these are the 3 areas. There's one more which I'm not supposed to talk. I think Niti Aayog knows about that. Maybe coming out pretty soon in this month itself, where we have worked. Now, all of this code that has been developed is open source. We've just given it. Okay, we don't hold anything, and they can run on any platform. So it's not tied to any IBM proprietary technology itself, right? So we are working on agriculture, health, education. Then we work with CBSE to define their entire AI curriculum. And the beauty of that was that we didn't say this AI curriculum with the, at that time, chairman was Ma'am Anita Karwal was there. We said it is not for technologists only, for the consumers also. Suppose somebody is going into BCom side of it. How would they consume AI, right? So a course for them itself. And it was totally tailor-made. It was not our learning services. Our 30, 40, 60 engineers got together for months all together, created the curriculum, taught the teachers. So in India, we are engaged in these 3 or 4 key areas. And we also announced on Monday that we'll be setting up a AI COE for government e-marketplace. So I think that's a wide stretch that we have with the government and the public sector. At state levels, different programs run depending upon the state policies.
Thank you so much, Gaurav. We need to move on. And the next, I'm very honored to get our next speaker, who is Dr. Shailja Gupta. She is a senior advisor in the Principal Scientific Advisor's Office, Government of India. She is responsible for the PM STIC mission on waste to wealth, the Deep Ocean mission, the COVID-19 response, and science outreach, including Core India and astronomy labs. I'm very glad to over to you, ma'am, Shailja ma'am. Ma'am, we cannot hear you.
getting my screen. Share screen. Can you see my screen?
Yes, ma'am, we can.
Okay. Good morning, everyone. And it's really an honor to be here on a panel of very learned men and have me speak. I'm not an expert on AI. I'm not an expert on any of the things my predecessors talked about. And somebody mentioned that it is great. I think Gaurav mentioned that it is great to have lateral thought in any discussions. And I hope to bring in the lateral thought in your discussions. Having worked in the government for the last almost 23, 24 years, it is an experience of what the government does, or what the government has to offer to the private sector, and what we can do together in the area of the developing area of artificial intelligence, I would say, in India. And if we look at, and everybody has talked about AI, and I will not talk about AI, how it impacts the various sectors in social sector. What is important is that when we look at AI, it says that if I share my, okay, can you see my full screen?
Yes,
Yeah.
ma'am, we can.
When we are looking at AI, we have to be, and this was a wonderful lecture which is available on YouTube, the Alan Turing lecture 2017, and it was by IBM chief, one of those big shots, Dr. Guru Banare. And he expounded the area. And this is, if you look at Google, and Google will give you a whole lot of searches about why AI and where AI can benefit the society. But the most important thing is humans, when we are going to, if we teach the machines to develop an artificial intelligence to work with humans, work like humans, and think like humans with compassion and common sense, we create a safety net for ourselves. We create a net which will prevent artificial intelligence from becoming the bad technology. Every technology, as we know, has a possibility and a potential of being good and bad in the same time. So to prevent artificial intelligence from becoming a bad technology, we have to look at how we can create the neural networks of the artificial intelligence to think like human, work with humans, not replace humans, but with compassion and good sense and common sense. We have to democratize artificial intelligence. Otherwise, we will continue with our 1% of privilege and entitled class. And again, the gap keeps widening between people who can access the technologies and people who cannot access the technologies. So, and enough was talked, previous speakers talked about local languages. It is important that we develop artificial intelligence in local languages. And every data which goes into the developing of the machine learning that machine learning and transforming it into artificial intelligence has to be in local languages. Till the time we do not teach our machines to think in local languages, it is not possible to democratize artificial intelligence for people who do not have access to the English language. Our narrative and our will be structured to an English narrative if we are not allowing the artificial intelligence to evolve in local languages. And therefore, we need to implement, and Gaurav talked about the the Jeopardy and the Deep Blue competitions, which was organized by IBM, and they were very successful competitions, but they were limited to an English-speaking population. So we need to have competitions and contests in local languages. We have to have data in local languages. We have to have tools in local Indian languages. India is unique in the sense that it is the only probably the only country which has multiple languages as their main language. And grappling with that complexity is one of the biggest challenges I see for artificial intelligence to develop as a social enabling accessible tool. We are looking at, there are context-dependent teaching and learning tools which exist in abundance over the net. There is the huge number of tools. And again, it is limited to a limited population and a limited class, the English-speaking people who can access these tools and learning and teaching tools. And again, when we're looking at, especially during the COVID crisis, we know when classes went online, the problems and challenges faced by children and teachers in resource constrained areas in the most rural part of the, not even such rural parts of the area. They did not have the tools of teaching. They did not know how to use the tools which were available on Google to teach, and neither did the students have the access to these tools. One child, one smartphone, most of the net, as you know, is accessed through the smartphone. And most of the students had one smartphone to 20 or 30 of them. And the teachers were equally handicapped with the lack of using these teaching and learning tools which are there but are limited because they are in English. So we need to have AI which needs to help map, identify and disseminate these tools in local languages so that it is available to everyone and everyone across the society. It is a challenge, and I'm sure IBMs and the Googles of the world will help us with it, hopefully. We have, and a lot was talked about AI for agriculture, AI for healthcare, AI for education, and AI for to improve cognition. When we talk about agriculture, and we have been working on predictive tools, and especially in the climate change scenario, where the climate changes and impacts sowing, harvesting, disease, pest, because of the changing environment conditions. AI has to provide predictive tools to farmers in the language they understand. How a delayed rain will impact their sowing patterns, how it will impact their harvesting pattern, how a disease because of the changing ecosystem will come unexpected, both for humans and for plants and agriculture. And this is where artificial intelligence will be very useful. But like my predecessor said, data is going to be the biggest constraint. Where do we get the data from? One is the data lying in our vast academic institutions. And Manindra knows that we have huge amount of data. But the biggest challenge is the data is in it is hard data, it is in papers, it is paper. Our first step towards getting the data should be to digitize all the data which is available in our academic institution, digitize it. Get hundreds and thousands and hundreds and millions of students to just digitize the data. And we have wonderful data there. Our scientists have been gathering a lot of data. We have been working on farmer zone, a concept conceptualized when the principal scientific advisor, Professor Vijay Raghavan, was in Secretary Department of Biotechnology, and I was handling the Farmer Zone concept. We worked with the Central Potato Research Institute, and we realized they have huge amount of data, which can be used well if it is curated and curated well in a way where it can be sensibly used for artificial intelligence. And there are hundreds of such academic institutions with large number of data available with them. You talked about geospatial mapping of the agricultural land in India. All of this data is available. ISRO has all of this data. And it has been the geospatial landscaping of the Indian geography regions have been done by ISRO. All of this data is available, and we should have to work with ISRO to sort of liberate the data which is available with them and make it available for the industry, for the academicians to be able to use it well and meaningfully. Professor Manindra Singh also talked about data which needs to be got from natural environment. Farmers are a good source of data, and he talked about, and I think that was a very good, how can my data benefit me? So if farmers can, and there is a very beautiful example of Plant Village, an FAO run initiative where they crowdsource the data from farmers. And farmers actually take pictures of diseases and variegated leaves and put it up on their on the website. Because it is crowdsourced from farmers, they have large amount of data, and predicting diseases becomes so much easier for them. So sourcing our data from farmers and telling them this is what it will, how it will help you, will lead to acceptance and adoption, as Gaurav mentioned in his talk.
Time-wise, maybe we have...
Yeah, and I'm going to my last point. If you look at what the PSA's office is doing, we have 8 missions on natural language translation, on quantum frontiers, artificial intelligence, national biodiversity mission, electric vehicle, and I think Gaurav or someone mentioned about electric vehicle and the batteries which you are developing, the bioscience for human health, and Eric Topol's 2 books on deep medicine and The Patient Will See You Now are 2 wonderful books to look at what bioscience data can mean to the patient and to the doctor. We have the Waste to Wealth mission, of course. We have the Deep Ocean mission. All of them have the bedrock of a huge amount of data and artificial intelligence eventually for the benefit of society. Thank you. And that's all I have to say.
Yeah. So, ma'am, thank you, ma'am. I have one question for you, because you're because from the policy side, that is a question that I want to ask. Yeah. Today, if we see a lot of the AI work, significant work is being done by these multinational, corporations such as, Google and IBM scale. And, one of the things that I see that, certainly there are in the academic space, there are a lot of people who are working on these things. But what I see at the government level, okay, I'm saying that we have to, because if we are interested in being Atmanirbhar, we must have the strength to do AI and at least understand the problems at a greater level of depth than we have today. And I just want to give you a small example. In the last 2 years, we've done a small experiment in Aadhaar, and we've actually got an example of about 20 AI actual practitioners who are actually building real models based upon the data that we have. Now, why can't this kind of thing happen, that we are actually becoming, actually practitioners of AI in solving long tail problems, because nobody else will actually solve it for us? Just wanted to ask your comment on that point.
So I think our biggest challenge is that we are working in silos. If you look at academic institutions, where the data rests are with the institutes of the ICAR, Indian Council of Agricultural Research. They have 120 odd institutions, and all the data related to agriculture is with them, but they are not connecting with the IITs, and where the whole mechanics of artificial intelligence is resting. And this has been the tragedy of this country, that we are not talking to each other, even though we have such deep knowledge in both the areas. And the second challenge is they have not been able to curate the data which they have right now in a manner which is maybe needed by people who are developing these machine learning tools. This is something which we have to, like I said, ISRO has immense amount of data, and which can be used so well in agriculture. But I think now things are changing a little bit, and they realize we have to break these silos and work with various organizations. And the distrust, and I think you mentioned, somebody mentioned the trust or the distrust between the industry not trusting the academicians and their data, and the academicians not trusting the industry with their data, is our biggest problem. And this distrust needs to narrow and come together. Only then we will be able to work together in a way which will be meaningful and work with for the benefit of social cause.
Thank you, ma'am. I think we have to move quickly. Our next speaker is Mr. Gaurav Agrawal, and Dr. Gaurav Agrawal is a research scientist at Google India. He has over 15 years of building computer vision and machine learning sources, both in academic and industrial settings. I believe he was at Ola before joining Google. So welcome, Dr. Gaurav Agrawal. We're running a little late, so let's get a move on. Thank you.
Yeah, thanks, Vivek. And I don't have any slides, so I will try to keep it short. A lot of points have been made by the previous speakers, and so I'll try to reflect on what Vivek started with. When we talk about scaling AI, I think Vivek talked about platformization of your solutions, going away from POCs and doing things so that they scale to the masses, like given our population and stuff. So I think, what I'll talk about is scale may mean a few other things. Obviously, what Vivek talked about, especially coming from Aadhaar, I think that that is critical. But as a researcher, for me, scale may also mean scaling it to the last man. Literally, like as Manish talked about, working on problems that affect the most have-nots, if you want to call them, and not just the problem of which are the tip of the iceberg. Then also it may also mean scaling to hard problems. While there are a lot of problems where which have easier or off-the-shelf solution, as I think others also talked about, and we can just use the existing solutions and apply them with the right intent. But there are a lot of harder problems which have not been looked at because they are hard. So I think we need to scale our efforts to solving hard problems, again, for the society. I'm not talking about the research problems for the sake of it. Then scaling it to more researchers. In India, I think we have very few AI researchers, to be very frank. I mean, if I were to give just some recent statistics, recently in NeurIPS, which is one of the top AI conference, it released its statistics on number of papers country-wise, and India, with its population, had just 19 papers out of 1900 total papers in this conference. Just to put things in perspective, Facebook and Google, just these two companies, have far more papers in this conference than entire nations. And India is, it's just 1% of the total thing. So I think we have to see where we are going wrong with regard to, focus on AI. We talk about AI, but we don't have as many researchers in India working on AI. Forget about working on AI for societal problems. So we need more researchers. We just somehow need them. And I mean, I think, and most of these, again, papers come from IITs or ISC, but, if you look at other colleges, they are far behind, and we have to do something to encourage those colleges to again do research, cutting edge research, so that we can handle some of these hard problems. Other things that I think Ma'am Shailja talked about was democratization. I'm really worried about it, actually. Given the way AI is going, it is all about having a lot of compute and a lot of data. And where are those powerhouses? I mean, I'm sitting in one, so I should not be talking about it, but that's the reality. Facebook's, Google's, Nvidia's. Why are they doing better than most in universities, even in US? I mean, I'm not even talking just about India. Like, compare them to MIT's, Berkeley's, Stanford's. These companies are able to do more AI research. I mean, you can have debate about whether it is research or engineering, but the reality is that's what it is AI today. And I think we are going away from democratization. While we talk about we are democratizing, but I think we are going away because the amount of the algorithms we are chasing today are so data and compute hungry that most other organizations will not be able to compete at the level playing field. So in fact, like, part of my research interest is about this. Can we do more with less compute? I mean, while there is a ongoing race to beat the numbers, but I think hopefully more and more people will spend time on doing with less compute and less data, because countries like India and other developing nations will never be able to compete with these hardwares and huge data centers. So we need more and more research on that front. We also talked about data. I mean, while we have a lot of data, but I think we are data rich, but we are probably not data intelligent. In fact, there's a session I'm part of tomorrow. And while we have a lot of data, I mean, India is full of data. We have a lot of people. So everything we do generates data, and we sort of collect it also. So I'll give you one example of, where having a lot of data versus are we using it as, I think there's a huge gap. So as part of AI for Social Good program that Manish talked about, so I'm working with a couple of NGOs. So one of them is Swasti. So Swasti is fairly well-known organization. So the project we are working with them on is about reducing the HIV infection incidence rate in sex workers. So just to understand the problem, right? I mean, so that I went to their office and to understand what data do they have. Like they said, and I was pleasantly surprised. They had like 21 different forms that they keep filling with the same beneficiary who they are, regularly in contact with. And they are like, typical longish forms. And I was like amazed. I mean, you have so much data. So as a researcher, I was like, wow, I mean, we can do a lot of things. And now the bummer, none of that is digitized. Other than one form, remaining 20 are never digitized. And their problem is like, we are already an NGO. I mean, how do you expect us to hire people to make this into Excel sheets or CSVs or whatever, right? I mean, that doesn't work. I mean, so although my original goal with them was to actually work on this AI problem, to sort of figure out who are more vulnerable sex workers and help them, educate them via different means. But I think the bigger problem that I figured there was like of digitization. OCR seems like a solved problem in today's day and age, right? I mean, there is hardly any researcher who works on OCR because we assume it is solved. But reality is, I mean, go and look at those Swasti forms, and I think anyone who has worked with government will probably relate to that. I mean, they're all like registers, right? A lot of registers and again, they are multilingual in general because they are again filled by humans. They are not just in English or Hindi or local language. They are typically multiple languages, and these are written while people are standing, they are sweating, they have like ink sort of spreading everywhere. Those are the real problems. So I think there is sometimes this sort of whole suite of not so interesting problems which actually are needed to scale anything for, especially when we talk about society. So just to give you a few examples of problems that I have worked on, like before this, I used to be in Ola. So Ola, we used to like, proud of something like we used to drive more kilometers every single day. I mean, through our cars, not individually, more than the entire road network of US, China, and India combined every single day. I don't know whether I should be proud of it. I mean, you're proud because our algorithms were working. Sad because that is the carbon footprint we were adding to. But again, so we thought, what can we do? I mean, so we actually got into interesting partnerships with Hyderabad and Bangalore. So we started using, so some of our cars had these telematic sensors. So we started collecting telematic data. So actually we started sharing, where potholes are, there are potholes in the city, and if the government authorities are fixing them. So without sort of making a big, hue and cry about it, we just worked with them, and actually every month or so we started sharing data, and they knew actually whether the pothole situation is getting worse or better. And so there are these partnerships which can actually happen between government and even startups, forget about larger companies with limited resources, and where like we can solve these problems. I mean, if you have lived in Bangalore or most Indian cities, I think pothole is a huge problem. I think people die because of it. Forget about just the inconvenience. And I was happy that we could at least address it, that it can be solved. And thanks to the authorities in Hyderabad and Bangalore that they are willing to take it, right? And actually checking it whether 2 months later that they solved some of them, or their contractor filled them properly, that they actually did they open again and stuff like that without any human in the loop. So which was great. In Google, as I said, one of the things I am interested in is that making sure that AI remain democratized. So a lot of my interest in research, while it is not directly related to social problems, but it is about doing more with less data and compute, and also making these models interpretable. Otherwise, using them on humans is risky. I mean, whether it is health or any other thing, right? I mean, unless you can explain your findings, your predictions, decisions, it is very, very hard to use them at scale. And we can't say, sorry, that was our error rate. That can't.
Gaurav, I think we
okay,
are.
I'll stop here. Yeah, cool. So that's it. So I just gave you a flavor of like scale can mean many things. And I would highly recommend, in addition to many of us working on social problems, we need many more of us in India who should be looking at these problems, looking at AI as a career option. Otherwise, we'll just have too many problems, like too many people, and we'll always be lagging behind the set of problems we need to solve. Thank you.
So thanks, Gaurav. I think it's a wonderful speech. I have a number of questions lined up, but I think I need to move on. The next, because we are running a little late in the session, our next speaker is Professor Sunita Sarawagi. She is the Institute Chair Professor of Computer Science and Engineering at IIT Bombay. She has taught and published research on various data and machine learning related topics at IIT Bombay. Her interests span several fields, including machine learning, analytics, databases, and statistics. Over to you, ma'am.
Yeah. Okay. So can you see my screen?
Yes, ma'am, we can.
Okay. So I'll just present. So yeah. I am actually different from all the previous speakers in the sense that I am in academia, and I'm different from Manindra in the sense that I have been doing machine learning and AI for almost 20 years now. And also I have been in industry. I have spent 2 years in Google, and I have also spent 3 years in IBM Almaden at various phases of my life. So I have seen machine learning and AI and their effectiveness or lack thereof, and the challenges of doing research both in industry and in academia. So I want to bring that perspective in my talk. So of course, we have heard about many societal problems that can be solved with AI. I will not go over them just in the interest of time. So, but one of the big challenges for academic researchers is that training AI models is extremely resource intensive. AI works, AI is amazing because it collects data from many different sources, it collates them, and it tries to extract patterns, which would then be used by many different people. And modern day AI is extremely resource intensive. Training each of the trained models, which most amaze us, require billions of parameters. They are trained on huge amounts of data. They consume a huge amount of energy, and therefore they are only affordable by a few large centralized organizations. And that's why, when you heard talks from Manish and Gaurav, you heard of many like really amazing applications and technologies which have been enabled with AI. And you will not see similar such success stories in my talk, because I don't have such access to huge amounts of data and huge resources. So instead, therefore, I'm going to use my talk to push two agendas. First, I would like to make a case to our government to make data more freely accessible to academia, so that academic researchers can work on these problems which perhaps are in the blind side of industry. So we need a coordinated scheme to continuously and organically collect data before any AI can be brought to bear. So, large corporations have figured out how to create this ecosystem of data collection in a very latent way through this trio of, you provide useful service to humans who will gladly share their data knowingly or unknowingly, and you make money through ads. And because those services are just so irresistible, people are happy to share their data. And now we need to figure out for our society, where many of our societal problems may not be monetizable, how do we create an ecosystem of continuous organic data collection? Perhaps data can be like the new tax, like the way in order to use a road, you have to pay a little bit of money. Similarly, if you want to use a translation service, or if you want to get advice on a particular disease on your agricultural crop, you have to, either pay tax or you need to sort of be supported by government subsidies. And we need to have think tanks worry about what are the right kind of such data to create and how to create this ecosystem of data collection, which would sustain us for the next 20-30 years. And once we have this data, we can go ahead and define grand challenge problems. It's not just in India now. AI for good is the rage. Everybody wants to be like the next good person who thinks about world hunger. Everybody wants to solve problems which are sort of meant for general societal groups. Good. And so all we have to do is define the problems, and then we will have enough researchers and we define the problems, we provide the data, and there will be no shortage of researchers. And Gaurav mentioned lack of AI researchers in India, but if we define our grand challenge problems, there will be researchers in the Indian diaspora, but also otherwise, non-Indian researchers who will be willing to work on our problems. So, recently I had two cases where we got very appetizing problems where AI could have been applied in, say, maybe making sense of legal cases, drawing wisdom from the 40 years of legal cases that we have. And in fact, some of this data, most of this data is digitized, but it's not accessible. And we need responsive authorities, which among the people who own this data, who work patiently with academia to make such data available to us. Another experience I had was with CAG office. And I know that in most of these organizations, people have their own battles, fires to fight. But if we have sort of a will to adopt AI for this larger AI societal problems for which we already do not have solutions provided by the Amazons, Googles, and IBMs of the world, we need to make our own unique data about our own unique problems available to the researchers and the NGOs and the startups who want to work on these problems. Of course, once we have the data servers available, then we would want to create these ML models, which have to be necessarily on the cloud and centralized. But the deployment of the ML models trivially scale to any number of users. Like the way, AWS and Google Cloud and Microsoft Cloud provide machine learning as a service, we should think of providing machine learning as a service for this public good AI applications. So actually, what in the next part of my talk, I'll just talk about some of the work we have been doing on the challenges that would arise if you were to use these centralized large-scale models in the field, where your deployment could be by users in very, very diverse settings. And then maybe there is some scope for democratic research in terms of how do you take an existing resource intensive model and customize it with limited data to specific domains? How do you address issues of calibration that Manish mentioned? And how do you make sure that your model is used in a robust and fair way? So many other researchers have talked about it, and I am just going to talk about some of the work that we have been doing in IIT Bombay on the specific problem of domain adaptation over the last 4 years. So domain adaptation arises, say, if you have a speech recognition model which has been trained over, say, the whole of the world's data, but if you want to now make it work particularly for the Indian accent, then you have interest in solving a problem of domain adaptation. Likewise, suppose if you have a translation model which such models are typically trained on news articles, and now you want to use it for having a conversation with a doctor sitting in AIMS in Delhi with a villager in Odisha, then you need to use a translation model. But then the translation models which provide these impressive accuracies on news data will not work on medical data. So we need to solve the domain adaptation problem to adapt a translation model to the medical domain. So there are several such problems in the Indian context. Many of these have been mentioned, like say in speech recognition, translation, language understanding, reading comprehension, where there do exist models which have been trained on worldwide data, but then when you try to use it in the Indian setting with non-English speakers, you face challenging problems of domain adaptations. So we have been working on various types of this domain adaptation problem. So one variant of this problem is domain generalization, where if you know that your model is going to be, you have trained a model, say in 10 different accents, but you know that this 10 is not the set of all possible accents that you will be seeing during deployment. How can you make your model robust to new accents? So we have say a paper in ICLR 2018 and another in ICML 2020, where we talk about various solutions to the domain generalization problem. Second problem, of course, is calibration. If somebody else has to use your model, then you better make sure that with every prediction, you correctly reflect your confidence on the predictions that you provide on the model. Then a third problem is domain adaptation, and we have been working on this problem in various different settings. So here in this paper, which we had in ACL 2019, we try to talk about how to adapt word embeddings which have been trained on generic corpora to a particular topic. We have also been working on domain adaptation of time series forecasting models which have application in agriculture. For example, if you want to make long range forecasting of climate and other weather conditions so as to use them to give advisories to farmers.
I'm running a little bit over time.
Okay, sure. So maybe I will skip this part. So another part, once we start creating this centralized model services, we need to be able to provide access to people to adapt their models in a low resource setting. So this is, we have a bunch of work in this area, and, I'll be happy to talk about them separately if you ask them. And I'll just end this last slide on what currently we are working on problems related to, to immediate societal context. So in fact, we are working on multilingual representation models for closely related Indian languages. So one interesting research challenge is that Indian languages are not like disjoint from each other. They are highly related. So how can we just maximally exploit their relatedness to do better than creating models separately? We are working on translation of lectures to code switched multiple Indian languages so that we further the cause of education. We are working on ASR models for Indian languages, again by exploiting relatedness of Indian languages. And we are working on long range forecasting of multiple time series, and we have some projects with government in Maharashtra where we are trying to deploy them in the agricultural setting. So with that, I will end and take questions.
Thank you, ma'am. That's a wonderful session. I think the point that you, which is very close to my heart, that basically the creation of the data sets and then creating a grand challenge. If we actually create the right kinds of data sets, we can solve various kinds of problems. And then we make the researchers around the world actually solve our problems. So, but what I see though is, ma'am, a lot of the research that we do is we have data that is there, but it is not accessible. And we need to do more research to actually make this data available and make this data as part of benchmarks. But I don't see people doing that because the data is there, and actually it's a technical problem to make the data available. There is, of course, there's a trust issue, but then, how do we actually make the data accessible? I think that's a wonderful area that we need to focus on, because unless the data is there, we will always be running far behind, the tech majors. So therefore, that's
absolutely. Yes. Yeah, I totally agree.
So thank you so much. Now let's move on to our last speaker before the demo today. That is Miss Lavanya Tekumalla, and she is going to be talking about. She's going to be talking about, I suppose, use of AI in actually finding data scientists. At least that's what I understood. Over to you, Lavanya.
Can you see my screen?
Yeah. Yes.
Okay, great. I'm Lavanya. Thank you for the introduction. There were great talks by everybody about various ways in which we can use AI for societal impact. So I have been in the industry for about 15 years, and right now I'm the founder of AI Phonic Labs, where we work in the space of education technology, and we are solving some interesting challenges with ML in the space of assessments and learning. But I'm not going to talk about that. I would like to take this opportunity to actually talk about some things that I think are a challenge that are preventing AI solutions to scale to solve big societal problems. So I have bucketed the challenges that I thought of into like 3 buckets here: awareness and ecosystem related challenges, data challenges, and execution challenges. So the first is awareness and ecosystem related challenges. So I'm sorry, there's a power cut. You probably cannot see my face, but that's fine. So most of applied AI research is initiated in academia right now, and sometimes in the industrial giants, of course, like the Microsofts, Googles, Amazons, and so on, IBMs, right? But as we have seen earlier, Gaurav said we need more people. Dr. Sunita said if we have a lot of researchers and if there's more data, we can actually get them to work on problems. But I think another element to add here is the way people are learning is changing. So earlier, it's the PhD students who used to do all the work, but now many people are actually learning machine learning in a very informal way. So they actually take Coursera courses, they self-learn, and they go to all these upskilling schools. And all these folks are also looking for problems to solve. So core research definitely makes sense, to have more researchers from the academia. But when you actually look at a lot of the applied research, there are many small tasks that need to be done. And it makes sense to leverage this workforce that is available in the form of people learning and transitioning to data science, for instance, and also a general practitioner who is not affiliated with any of these bigger institutions. So can we crowdsource these problems? As it was mentioned earlier, if we could identify the problems correctly, so there are a lot of, even if data is available, a lot of us are not sure what problems to solve. So if the task of identifying problems itself is a very important problem to solve first. So if someone can actually identify problems and create data sets and make it accessible not only to the researchers, but to the general public, there are a lot of people who are picking up data science tools who can actually now try to solve at least parts of these problems. So the next is bias in terms of the problems we think of. So we tend to pick problems where data is available sometimes. Then there's lack of diversity in applied AI researchers. So for instance, female participation, different ages, different languages or regions in the country and so on, right? And also there's lack of participation from the consumers of applied AI research. So for instance, if I'm developing language translation technology, I might have spoken with somebody, with the languages I'm working with, but not necessarily people in rural India who might be the consumers finally for whom we are actually doing this. So it might make sense to engage the end consumers. So if we have domain-specific events where applied AI researchers and the consumers, and when I say consumers, it's the end consumer, like, the farmers or, the whoever for whom we are developing the technology can participate in the ecosystem. I think that will enrich the perspective of everybody and we come up with better problems to solve. Then there's been a lot said about data and infrastructure challenges. So there's like lack of large-scale data sets, lack of data infrastructure, low quality data, available data is skewed and biased, and privacy issues, and so on. So we need to focus on infrastructure. But one thing I want to mention here particularly and call out is that we need to track the right metrics, and we require data not just for the specific subtask we are solving, but at every stage in the pipeline so that we can measure outcomes. So for instance, if we actually, in the space of education, suppose I help, I have translated some videos to help folks learn in like rural India. I would need to know finally how many of them actually ended up getting jobs because of that. That would be helpful. But that is really hard to tie up right now because we need data from various pieces in the pipeline, and not just, data for a single task that we are, not how many people used my app or not how many people, how much time they used it for. So the third bucket is execution challenges. I think it takes a lot of time to create impact, measure, and reiterate. And it requires focusing on outcomes again. And this requires like a long period of time. So maybe there needs to be some way of organizing more longer term grants over like 5 years to 10 years to solve such problems. And finally, the participation is lower. So what I mean by this is, what incentives do private players have to solve big societal problems? So if you take a general data science practitioner, what will motivate them to solve big societal problems? So the other thing that was pointed out earlier as well is that we all work in silos. So it's hard for small teams to make an impact on their own. And there's no collaboration between teams to solve bigger problems. So AI needs to be put to use with nuts and bolts, not as a monolithic structure. And in this context, there's one thing that I want to particularly mention to finish whatever I'm saying. From my personal experience, I've seen that during the pandemic, a lot of data scientists from various organizations started to informally work together to solve problems related to COVID, be it forecasting or cleaning up data or collecting data or figuring out what problems to solve for COVID. There were a lot of people from top companies like Amazon, Google, Microsoft, Flipkart, and several startups. And this resulted in a lot of informal collaboration. And here are some examples of some consortiums or some groups that were formed, very informally worked together and came up with some solutions. Maybe they interacted with the government war rooms in some cases. But the point is, there are people who are willing to spend time and solve problems for India. And if we can somehow harness this energy that's available and recognize them, and maybe if necessary fund informal people who are trying to work towards general data science practitioners who are trying to work towards these problems, I think we have a chance to scale solving, putting AI to use to solve big societal problems even better. Thank you.
Yeah, thanks, Lavanya. I think that's a wonderful presentation. I think some of the points that as a practitioner, I see that you have raised are actually wonderful. And I actually would like to say the last point that you had made about COVID-19 data being available. I think there has never been a case that we have actually had public data being collected in such a connected way. And so many people, both those involved in the government and those who are not in, well-meaning people, and how they brought together and how so much data was, and our understanding of data in this pandemic actually has actually opened our eyes that if data is available, what kinds of things we need to do. And many of the points that you raised, I think are very, very relevant. And I think that, it's a wonderful talk. So therefore, thank you so much.
Thank you.
So I think we are running a little late on our, as far as our panel is concerned. So, so I'm going to actually move I'm going to move to the final demo that is going to be given. And so therefore we will be running about 15 minutes longer than 10 to 15 minutes longer. So I'm going to actually introduce Mr. Sela Nevo, who is going to be the demo speaker today. He is a senior software engineer at Google. Mr. Nevo specializes in machine learning and development and is committed to enacting large-scale effective social impact. And he's focusing on global poverty and health. He is currently leading the Google Flood Forecasting Initiative, which aims to provide scalable, high-accuracy flood forecasts and warnings globally. So, and I think that, and he's going to actually demonstrate what they have done as part of the Google Flood Forecasting. So thank you so much. Over to you, Selo.
Thank you. So thank you so much. It's really truly inspiring to see the breadth of work in this session. And in this talk, I want to deep dive into a specific AI-based solution in a domain that I believe is incredibly impactful, flood forecasting. For about a decade now, Google has been providing people around the world with real-time alerts and information during crises and natural disasters. To do this, we collaborate with governments and international organizations to help make sure that critical, life-saving information reaches the people who need it. We use Google Search, Maps, and Android notifications to alert millions of people within seconds of when a relevant agency issues an alert. But a few years ago, we realized that distributing existing information is not always enough. For example, we visited the Agrawal village in Bihar only a couple of days after the flood you're seeing now. When we arrived, only a handful of houses were left standing. There was no warning for this flooding, and while this video was taken during the day, floodwaters originally began to rise at night while everyone was sleeping. And when people woke up, for some of them, it was already too late, and 2 people died that night. Sadly, this story is not an outlier. Floods are the most common and one of the most deadly natural disasters on the planet. Every year, they affect hundreds of millions of people and cause between thousands and tens of thousands of fatalities, many of them occurring in India. However, on the brighter side, much of the harms of flooding are also incredibly preventable. Early warnings have been shown to double the number of people who evacuate and take other protective actions, and significantly reduce fatalities. This is why we've started the Google Flood Forecasting Initiative. We believe everyone should have access to forecasts and warnings so they can be safe and informed. And for that to happen, the underlying technology has to be one that is computationally scalable and sustainable enough to span the entire globe. We currently focus on riverine flooding, as opposed to flash floods, coastal floods, and other types. So why is Google involved in this at all? There's a lot we believe Google can do to help to move the needle, from reaching affected individuals quickly through utilizing Google's computational resources, and all the way to what we believe will be our largest contribution in this space, using our machine learning expertise to significantly improve the quality of these models. Yet we recognize that we're in an assistive space in this role. Governments are the ones with the infrastructure and the mandate to take care of the safety of their citizens, and most of the relevant experience and expertise lies in organizations that have been doing this important work since before Google was even founded. That's why we began working together with the Indian Central Water Commission under the Ministry of Water Resources, as well as the National Disaster Management Agency, to improve flood forecasting and warnings across India. Broadly speaking, these kinds of systems can be divided into 3 components: the hydrologic model, the inundation model, and the distribution of the resulting warnings. Let's go over them one by one. Let's start with the hydrologic model. The hydrologic model is the main component that allows us to forecast into the future. It accepts inputs like precipitation, temperature, stream gauge measurements, and more, and produces as an output a forecast for discharge or water level throughout the river. Now, the classic way to implement these models is to have each component implemented as a separate physics-based model. In practice, since we don't have nearly enough information to actually define kind of the full physics of what's going on there, we use simple conceptual models. This methodology has several limitations, from a simplistic representation of the processes involved, through large amounts of overfitting, as well as the requirement of continuous manual calibration by experts, leading these models to be expensive and not scalable. We replaced this conceptual modeling with LSTMs, a neural network architecture specialized for time series. We don't explicitly model almost any part of the process, but allow the network to learn more complex representations than classic models are able to support. We've been able to show that these LSTM-based models can achieve significantly better results than the classical ones. Each line in this graph represents a classic hydrologic model used in operational systems across the world. I won't have time to fully explain the graph we're seeing right now, but what you really need to know is that closer to this corner at the bottom here is better. And here we see the performance of the LSTM-based models. Not only are they more accurate, but what you can't see on this graph is that they also scale and generalize better. These LSTMs are trained across hundreds of sites with a single click, as opposed to the classic models, which need to be calibrated manually across each site specifically. They're also great at generalizing to areas where we don't have data. The specific comparison you're seeing right now compares classical models which were trained specifically for the site they're being tested on, while our LSTM-based models have never seen data from the site that they are predicting for. We're continuing to improve these architectures. Recently, we've been working on creating models that can communicate information to downstream sites, as well as combine transfer learning between sites with per-site specialization. But while it's always fun to talk about the academic breakthroughs, it's no less important to tackle the practical issues that are inherent to real-world data and operational systems. Reducing data latency, detecting and correcting errors in data collection, and increasing the speed and frequency at which these models are run is less sexy, but critically important to take these models out of academia and allowing them to actually create change on the ground. We've deep dived into the hydrologic model. Now let's move on to the second component of an actionable flood forecasting system, the inundation model. Inundation models simulate the water's behavior across the floodplain, like you're seeing on the screen right now. This allows us to understand what areas exactly are going to be affected by an upcoming flood, and it means we can identify in advance who needs to be warned of danger, and no less importantly, where they can go to be safe. The classic way these models are implemented is through physics-based simulations called hydraulic modeling. These involve solving differential equations on a grid. Originally, we've implemented such models ourselves, so we can run them on Google supercomputers and specialized hardware. But even if you have a perfect model, there are still a few challenges to address. Here we can see an example of one of the first alerts we ever sent out in Patna. Blue areas on the map are areas that were flooded and indeed received an alert. Purple areas are areas that were not flooded, but still received an alert. We wanted to warn people who were close to flooding as well, and so we felt comfortable with the purple buffer you can see surrounding the flood. Red areas are areas that were flooded, but did not receive an alert, and obviously are a big problem. As you can see, most of our red areas are incredibly small, which is great, except for that pretty big red blob at the top there. For a long time, we couldn't understand what was going on with that area. We looked at the topography of the area, and it was just physically impossible for water to reach there. There was an enormous embankment between the river and the area that we're seeing from satellite data is flooded. After being frustrated by this for months, we ended up flying to Patna and talked to some farmers in the area. Apparently, when they want to hydrate their crops, they just dig a hole in the embankment so that the water will flow through. Now, of course, there's no way for us to see this based on the satellite data that we have access to. And moving to find fix each one of these errors anywhere in the world. So on the other hand, we do see that this place gets flooded, and it gets flooded quite consistently. So we started wondering, why can't we have our models learn this automatically? This is just one example of many things that we know we don't know. The data we use can sometimes have errors, and we often don't know the riverbed bathymetry in addition to these kinds of underground that we can't see from afar. These issues pushed us to start incorporating machine learning into this component as well. We'd like to train our models to automatically identify behaviors they've seen in the past, especially where our physics-based modeling gets it wrong. But of course, we'd also not want to not abandon all the information that we do know. Most of the elevation map, for example, we know pretty well as the core, physics-based principles underlying these processes. We want a solution that can learn from the data that we see and fill in the gaps that we don't know, while continuing to utilize the core principles that we are very certain of. We've developed what we call the morphological model. It combines a machine learning model to estimate the river profile, which is fairly simple to learn, but we have relatively little prior information about, with a physics-based model to expand that profile into the two-dimensional floodplain, which is harder to learn, but easier to understand from first principles. Based on these tools, we can produce highly accurate flood forecasts at scale, like you're seeing here. But of course, it's even more exciting to see this accuracy in real life. While visiting Bihar, we did what we don't recommend other people do, and we drove up to where our warning said flooding should begin. And what we found is this: exactly as we arrived to where our forecast said should be flooded, we found the beginning of the actual inundation. Of course, the reason we do all of this work is so we can warn people and protect them. We have three main strategies for doing so. The first is what we call Google Public Alerts. This is an infrastructure that allows sending emergency messages to people in affected area through Google Search, Maps, and Android notifications. We provide detailed information about flood extent, inundation depths in your local area, and more. Over the past few months, we've sent more than 35 million warnings to individuals affected by flooding. We also collaborate with the relevant government agencies, including the disaster management agencies, as well as others, so to make sure they have this information and can act on it. Governments have the mandate and the infrastructure to help in the short term through mitigation and relief efforts, and in the long term through critical infrastructure work, such as building dams and embankments. Finally, we know many people who need this information don't have access to the internet. That's why we fund and collaborate with local NGOs so they can provide this information to those in need who are not connected to the internet. We've recently started a collaboration with the International Federation of the Red Cross and Red Crescent Societies. This work is funded and supported by google.org, and it allows the Red Cross to notify both community members and local officials through their volunteers on the ground. These tools are not only more accurate, but allow us to be much more scalable. They allowed us to go from covering about 1 million people in our first pilot launch in North India in 2018 to 10 million people in 2019, up to 200 million people this monsoon season in 2020. As we expand, we're finding people are not only reading our alerts, but sharing them with their communities, helping make sure that their neighbors and loved ones remain safe as well. To conclude, our vision is to use accurate hydrologic models that give days of lead time, actionable inundation models that are spatially accurate, and fast warning distribution systems with high penetration, and to scale all three of these globally so that anyone affected by floods will have the information they need to stay safe and informed, no matter who they are and where they are in the world. And that's it for me. Thank you so much for listening.
Thank you, Selo. That was actually, that was a wonderful presentation, and actually a real world example of how you can scale AI to actually solve a societal problem. And it is fantastic that you're saying that 200 million people in India are actually getting benefit of the work that has been done there. So I mean, I think that's amazing. And now when you say that it takes you time, say you move, obviously you have scaled impressively from 1 million people to 200 million people, but just from a machine learning perspective, AI perspective, what does it take for you to actually increase the coverage of these systems? And if you can just briefly talk about that.
Yeah, so I think at the moment, there is still a minimal amount of manual work needed to set up the data. And this touches on a lot of things that people in this panel have discussed, which is, making that data accessible and in format that is relevant to be learned from. And also there's constantly the challenge of generalization. So at this point, it is very easy for us to expand to areas that behave very similarly to the ones that we've seen so far. But whenever we move to a new region and a new climate, we find that there are other conditions that, because we haven't trained on yet, still require some adaptation. So I think that's where most of our constraints come from.
And just as a question, and this is you might is this effort open source, because this is something that clearly is of public importance, right? So and if other people want to understand how these models work and review it, is that available? I mean, because obviously, as you said, if you get it wrong, it hurts people, and as people believe it more, the impact can be greater.
Yeah, definitely. I totally agree, and I agree that open sourcing is kind of the path to making this truly scalable and revolutionary, so that other organizations can use it as well. Parts of these systems we've already open sourced. So, for example, the LSTM-based models that I mentioned before are open source and can be used by anyone. Parts of these systems currently, and this again touches on, I think, what Gaurav has mentioned before, parts of these are currently still too data hungry and computation hungry to be used by other organizations, and we haven't open sourced them yet, but we are working hard to try and make them more efficient and usable by the general public, at which point we will also open source them.
And one final question, how much data did you need to get from governments or other third parties to actually make this available, and how does that work? And just wanted to understand that. To actually run your models, obviously, to do the alerts and other things, I'm sure you're working with the authorities, but to actually build, to make your models run.
Yeah, so this work relies quite critically on the collaboration of our government partners, both in terms of the data that they provide, and most critically, the stream gauge data, so the measurements of what's going on in the river at the moment right now. As well as their expertise and guidance on what kind of alerts we should be sending out, and what are the thresholds for deciding when to alert people. So that is the data that we most critically rely on, but any additional data that they can provide that's better than what's publicly available, like precipitation data, elevation maps, river bathymetries, and so on, can also significantly improve the quality of these systems.
So thank you, Shailja. That is actually wonderful what you've presented here, and I think is a true example of how AI can be used to scale social good. I think we are running a little late on our things. Unless anybody else has any final comments, I think maybe I'll leave it for one or two comments, and after that we can close this session. Thank you everyone for participating. I think it was a wonderful. I think I learned a lot in this session myself, and I think that I would like to thank all the speakers for their participation here to make this a very informative session for the audience. Yeah, anybody wants to comment, we can have a couple of comments and then we can close.
So I'll just comment that what Sunita was talking about, it's not just, we have to solve these problems in India, but Shailja's team is a great example where like most of this work was done by Google Israel regarding the flood forecasting, and it's helping 200 million people and counting, right? So that exactly is a testament to like what Sunita was talking about. If we can work, I mean, there are a lot of researchers out there who can work on social problems in India.
It's a great example of a industry academia partnership and the government as well. Thank you, everyone. Thank you so much.
Absolutely. And I think the government is a very, very important.
Yes.
Thank you, everyone. Thank you for being here. And we are going to end this session now. And thank you for everyone for participating. Thanks.
Thank you.
Thanks, Vivek. Bye.